Hello, welcome to the parallel line construction video. I know that we went through this in class already, but I wanted to give you guys some reference. So we're going to go through this one more time and hopefully get all the details in there for you. So we're going to do the first one, parallel through a point. This is the one that's an angle copy method. Okay, what I like about this angle copy method is this is very closely related to what we're doing in this unit. Not only does it involve parallel lines, but it's using one of our properties to go through it and find that parallel line. Okay, so everything is going to start off very similar to this. You got point R on the outside and line PQ. Step one, draw a line through R across PQ at an angle, creating point J. They just don't want this to be a vertical line that's perpendicular to line PQ. Okay. And I like how it's extended in GeoGebra. You would want to make a full line, not a segment. With the compass width about half of JR, so about half this JR length, and the point on J, draw an arc across both lines. Using the same compass width, repeat at point R. And essentially, we're just setting up this angle copy. Okay, and because we're using the same line or ray for one side of the angle, it's going to allow us to get these things synced up pretty good. Set the compass with the lower width to the lower arc. So we got the lower arc here. We're going to move it up and draw that intersection of arcs, making that point S. Draw a straight line through R and S. And we have line RS that is parallel to PQ. Now what's really cool about this, again, this is where it really corresponds with what we're doing. These are corresponding angles, okay? At the two intersection points, they're up and to the right, up and to the right. We copied the angle, and because we know the angles are the same and these lines are parallel, okay, that makes these lines parallel. Same thing would happen if we could say these angles are congruent if we knew the lines were parallel. Well, it works both ways, okay? It's one of those statements that we can use with if and only if. We could say lines are parallel if and only if the corresponding angles are congruent. Well, we could also say the corresponding angles are congruent if and only if the lines are parallel. It goes back and forth. So that's our first example. The second one is going to be the rhombus method. Again, things start off the same. Point R on the outside, line PQ. Set the compass on R with the width a little beyond the line of PQ. This is the one where we're going to want to draw, basically, there's going to be a rhombus. This is going to be the top left point of the rhombus. We need a point here, and a point over here. All right? So we need it to cross two places. So two places along our line and to the right of the point. Draw an arc that crosses PQ twice and up past the right of R. Okay? Every point on this arc is the same distance from R. So I know that the rhombus side here and here will be the same length as long as the points are on the circle. I'm going to use this length because it's a consistent length now for the sides of our rhombus. I'm going to move down to J. So now the flat bottom part of our rhombus will have that side will be the same length. And we're just going to move things over to point E. And we're going to get that intersection, which then gives us the right side of the rhombus will be the same. So we have the points, the four vertices of our rhombus down here. We have J, E, S, and R. But really all we're concerned about is that top part of our rhombus, because we know the top and bottom sides are going to be parallel. And we're just drawing that parallel side. Okay. So that's the rhombus method to get our parallel lines. And our last one is the translated triangle method. All right. So here, again, this one looks a little different, but it's the same idea. You've got point R, which is up there. what we're going to do is we're going to add A and B anywhere to PQ. Now, just be careful when you're doing this. Make sure A and B are somewhat close to point R because they're going to be the other two vertices of the triangle that goes with R. All right, and make sure you just leave enough space so you can translate this within the 2 points that are given on the line PQ. Draw lines AR and BR forming the triangle. All right, now we're going to start basically moving a couple of these pieces over as we slide the triangle along this line PQ. Mark a new point A prime anywhere on PQ. Again, just make sure you're putting it at a point that that distance between A and B, you're going to have A prime and B prime. Make sure it fits within P and Q. We're then going to measure the distance between A and B using a compass. And we're going to take that measurement and draw an arc. And we've got point B prime. So now we've got the same AB and A prime, B prime. Those are the same length. Now we got to find R prime up here somewhere. So what we're going to do is we're going to measure the distance between A and R, draw an arc, and we're then going to measure the distance between B and R. And we're going to get that intersection of arcs, which would be R prime. Last step. Okay, well, I guess we can make our triangle, okay, which completes the translation of the triangle. And to get our line that's parallel, we just connect R and R prime. And there we go. Okay. All right. That covers the 3 ways that you can construct a parallel line through a given point. I want you guys now, a little bit of a challenge. I want you guys to take what you see here, which is kind of a digital representation of how we would do it manually on paper with a compass and a straight edge. And I want you guys to do it on GeoGebra, okay? And there's an assignment that goes along with this. You're required to do at least 2 of the 3, but if you do all 3, you guys get 5 bonus points, okay? Good luck on the assignment, and I'll talk to you later. Bye.